So some examples on basic function theory. Okay, so the first one is if you take the example that I've given there, I've given you f of x is equal to 4x plus 3 and g of x is equal to 3x squared. Okay, so you're asked to evaluate f of 3. Okay, so everywhere you see x, you replace it with 3. So it's 4 by 3 plus 3. So it's 12 plus 3, which gives us an answer of 15. So f of 3 is equal to 15. In part 2, you're asked to evaluate g of minus 1. Okay, so you take the g of x function, and everywhere you see x, you replace it by minus 1. So it's 3 by minus 1 squared. Don't forget that when you square a negative number, you get a positive number. So minus 1 squared is 1, so 3 by 1 is 3. So g of minus 1 is equal to 3. Part 3, you're asked to evaluate, and it is f of 2k. So you take your f of x function, and everywhere you see x, you replace it by 2k. So f of 2k is equal to 4 by 2k plus 3. So that's going to be 8k plus 3, and that's the final answer. And then in part 4 of this, you're asked to evaluate g of k minus 3. So you take the g of x function, and everywhere you see x, you replace it by k minus 3. So it's going to be 3 by k minus 3, and you're going to square that. So it's going to be 3 into k minus 3 by k minus 3, which is going to be k squared minus 3k minus 3k is minus 6k plus 9. So you're going to get a final answer of 3k squared minus 18k plus 27. So now moving on to important examples also, which are determine which of the following are graphs of functions. So you're given the graph, and then you're asked to say whether it's a function or it's not a function. So what you will use is you will use the vertical line test. So you can draw the line on, or you can just take your ruler and just see. Okay, so this first function is a graph is a function because a vertical line intersects the graph only once. Remember, that's the criteria. It can only intersect it once. So yes, it's a function. Okay, now if we look at part 2, it's not a function, because if you're to move your vertical line across, there are x values in where you will get 2 y values. Okay, so this is not a function because the vertical line has the potential to intersect the graph more than once, so it's not a function. Okay, and if we look over here, this is also a function because if we move our vertical line across, it intersects it just once. So this, yes, it is a function. Okay. So now when you're looking at an interval, and this is very important to understand this, when you're looking at an interval, knowing how to read it and what it means and what the brackets mean are very important, okay? So if you're given the function or the relation where x is an element of our real numbers, and your x values are greater than or equal to a but less than or equal to b. Now once you see the equal to, you can use your square brackets. Okay, so you have your interval is between A and B, and they're both inclusive because of the square brackets. Now in the second example here, the relation is x is an element of real numbers, okay, where x is greater than A and less than B. So A and B are not included, so we use round brackets, so A and B, so that denotes that A and B themselves are not included. So in the second type of relation, you have x is an element of or real numbers where x is greater than or equal to a. So once you see the greater than or equal to, you'll have a square bracket beside a, and it's less than b. So once it's less than, there's no equal to there, so it's a round bracket at b. And the last one is x is an element of real numbers where x is greater than a and less than or equal to b. So greater than a is not included, so therefore it's a round bracket at a, and less than or equal to b, b is included, so it is a square bracket at b. Okay, so this example down here is very important. Okay, so you're asked to examine the given functions and their graphs, and you're asked to state the domain, the codomain, and the range of each of them. I would think this a possible exam type question. Okay, so you're given a function and they're real numbers where where it goes to real numbers and x your input values, and these are your output or your y value is x squared minus 2x plus 8. Okay, so now reading it properly again. Okay, so f is the name of the function. Okay, and this here is your domain. Okay, so for the first graph there, the domain you're given is OR. Okay, so it's the set of real numbers, so that is what you write down as the domain. It's the set of real numbers, or you get away as just writing down OR. Okay, now the codomain over here, okay, is also the set of real numbers. Okay, so the codomain on the other side of the arrow, so the codomain is also the set of real numbers. Okay, now the range. To get the range, you look at your graph. Okay, so the range is going to be your output or your y values. So it starts at 4. Okay, and 4 is included here. 4 is an exact y value, but it goes on and on and on and on and on, and there's an infinite number of outputs or y values. So how you write that is a square bracket, and you have 4 because 4 is included, and it goes as far as, keeps going to infinity and on. Okay, so that's why I have my round bracket there. Okay, so moving on to part 2 there, so we have the g function. Okay, so you're told that now your round bracket is a giveaway. Okay, so 0 is it goes on before 0, and 2 is included with your bracket, and your codomain is OR. Okay, and then you're given your output is 1 over x. Okay, so first thing we're asked for in part 2 is the domain. Okay, so the domain are, if you look here, you're told that x is greater than 0 but less than or equal to 2. Okay, so x values are greater than 0 because you're round bracket, and less than or equal to 2. Okay, and you can state that x is an element of OR there. Okay, but those values just fall in between greater than 0 and less than or equal to 2. Now your codomain is easier to find because your codomain is here, and it's the set of real numbers OR. Okay, so the codomain is the set of real numbers OR. Okay, now so to find the range, okay, so the range you're going to have to use your output. Okay, so for the range what you're going to have to do is, you know that g of x is equal to 1 over x. Okay, and you know that one of your input values is definitely 2. Okay, so x is equal to 2, or g of 2, which is 1/2. Okay, so you know that at 2 on your graph, that your corresponding y value is 1/2. So your range starts at 1/2. Okay, so we know that the 1/2 is definitely included, so we use our square bracket 1/2, and it goes on and on and on and on, and it's an infinite number of y values, so it goes to infinity, and we use the round bracket. Okay, now if we look at part 3 here, we're told the name of the function is h. Okay, and we're looking for the domain. Okay, for part 3. Okay, so the domain is the set of real numbers. Okay, so the set of real numbers. or. Okay, set of real numbers or. Now the codomain, and you're told that the codomain is between -1 and 1, okay? So you can just write that down, -1 and 1, okay? And the range, if you look at the graph, the range is also, and the dead giveaway is because it's a cosine graph, the range is between -1 and 1.